today. All right, so let's start with, I probably won't do all of them, but let's do a couple of them. Do you guys have a preference between 4 and 5? Which one I do? I feel like 4 is probably more difficult. You think 5 is more difficult?
Yeah.
Well, let's talk about 5 real quick, okay? All right, so yeah, you can do this one in 3 steps. This one's kind of nice. So
Can't you do it in 2 steps?
2-step? No, you got to do it in 3.
Isn't it just angle on the side though?
Well, so it gives you an angle on the side, but then you need to.
Vertical angle.
So there's your second one, but then your third one's got to be your proof statement. So then angle W congruent to angle Z, and then VW congruent to YZ. So Liam, I'm going to pick on you. I start by stating my givens. And then Dom already kind of told us. But do you see how I have like 2 pieces of information in each one of my triangles?
Yeah.
So what I like to do is I like to list my pieces out. So like this is an angle here and then a side here, like in my given. So then the next thing I'm going to do is look at my givens. And I think some of you guys get stuck at this point, but I'm going to look at my givens and say, okay, is there any like vocab words that I can use, like midpoint, bisector, perpendicular, anything like that? There's nothing there. So then what I'm going to do next is just go to my picture and see if I can get something for free for my picture. And you kind of saw in the ones that are on the board over there, what I can get for free is the fact that these are vertical angles in the middle, which Dom said as well too. So then what I'm going to do is I need to list that. Okay, so it's one thing to mark it in my picture, but then I need to say angle. And then when you guys say your vertical angles, don't just say angle X. You need to have 3 letters. So I'm going to say like WXV is congruent to angle ZXY. And then the reason for that, well, it was because they were vertical angles. So I'm going to say vertical angle theorem. Cool. So I showed another angle. So like I'm keeping track over here and I see like, okay, I've shown 1, 2, 3 pieces of information. That's probably enough to show the triangles are congruent. Because if you look at all those acronyms up there, 3 pieces of information, right? So then here's the important part. You guys see how I listed it like angle, side, angle here? That doesn't necessarily mean that's the proof technique I'm going to use. It is related to the picture. So like in this picture, the side that I showed was this side. Is that side between the 2 angles that I proved congruent? Yes or no? Is that side connecting those 2 angles that I showed congruent?
No.
No, that would have been this side right there. So because that's not angle, side, angle, and instead it's angle, angle, side. Good. So then I would just say the proof statement. So triangle, I just copy it down exactly like they give it to me. VWX is congruent to triangle YZX. And then the reason for that is you guys told me angle, angle, side theorem. Does that make a little more sense?
Yeah.
We'll keep doing more. All right. Let's talk about 4. 4 is tricky. We're going to do a little bit of planning before we go into 4. Let's look at the givens. So it tells me those 2 sides are congruent. They already marked them in my picture, whatever. And then as I'm writing my givens down, I see that my other given is the fact that they are perpendicular. So what should I be thinking in my head when I see that I have a given that's perpendicular? You said what? What should I be thinking in my head if I see the 2 sides are perpendicular? They form 90-degree angles, which could also mean what else? What, those 2 angles are equal? Is that what you're saying? Those 2 angles will be congruent, that's true. But the fact that it forms 90-degree angles, right angles, means I could potentially use what? HL theorem, right? So because of that, let's plan out my proof before I kind of go into it. So like, okay, cool. That means these angles are right angles, okay? I can either use the fact that they are congruent, or I can use the fact that they're right angles making a right triangle. What other piece of information can I get from the picture? Do you need another copy? Okay. What other piece of information could I get from the picture number 4?
That the two sides are congruent.
Which 2 sides, Clark?
AB and BD.
Good. No, not A, B, and B, D. Those are already given to me, my friend.
AC and CD.
Nah. You only got one left. BC and BC. Because they're what? Good, Prabner. They're reflexive sides. Okay, so let me ask you this. This picture is marked the way that it is. Which proof pattern does that fit? Is that, it's not side, side, side. I have 2 sides in an angle. So is it side, angle, side? Is that angle between the 2 sides? Well, these are the sides that I know. I know this side, and I know that side in that triangle. Do I know that angle that's formed by those 2 sides? No. So can I use side, angle, side? No. So because of that, what proof technique am I going to use? Nope. HL. Do I have my hypotenuse congruent just from what I marked in there? I do. Do I have a pair of legs congruent? Yep. And is it a right triangle? It is. So then that's what I need to show. Okay. All right. So let's go through and state that. Now, this part, I think I can't remember if I did this with you guys in class yesterday. Did I talk about like stating that they're right triangles in class? I don't know if I did. I think I did, right? You have to state the right angles and then state the right triangles. Here's how this should look, okay? I know that those 2 lines are perpendicular to each other. So from that, you guys get right angles. So here's what I need to say. I need to say angle ACB, comma, angle BCD, no, DCB, are right angles. So if you don't have that in your proof, write it down. Those 2 angles are right angles are what you need to say, okay? What's the reason for that? Very good. Definition of perpendicular, because the lines were perpendicular to each other. Okay, so here's where this goes for HL theorem proofs. If I know that those angles are right angles, what can I say about the triangles? Yes. So I'm going to say nearly the exact same statement that I did for 2, but everywhere there's an angle, I'm going to change it to a triangle. So I would say triangle ACB, comma, triangle DCB are right, triangles. Okay, I don't know how in depth I went with that yesterday, so I wanted to make a big point of saying that now. How do you know they're right triangles? It's a definition. Definition of right triangles. Okay. All right, so then that gives me that the triangles are right triangles. I already stated that my hypotenuses are congruent. I need to state now what Probnor told me, which was what, BC and BC? So BC is congruent to BC, and then the reason for that is reflexive. I think I forgot to take attendance. Reflexive property. Hey, I'm here. Yes, I can. Thanks, Kira. All right. So then I stated hypotenuse is congruent, legs congruent. I stated that they're right triangles. So now the last thing I'm going to say is that those triangles are congruent. So then triangle ABC is congruent to triangle DBC. And then the reason for that would be HL theorem. Okay. HL is a little tougher because it's different than what you guys have done so far. I mean, we did like the side, angle, side, like all that stuff is very similar to each other. The HL theorem is like a special case, so that one is tends to be a little trickier. Okay. All right. Let's do some more. Okay, let's do the back. So the back relates to what I was talking about, like for 6 and 8. You thought I was going to say the number. For 6 and 8, those relate to CPCTC, which we started talking about yesterday, but I don't think I ever fully finished. Julia, what's up?
I was wondering, since you have H algebra, you may be able to justify why the other one would be congruent. Because of the Pythagorean theorem, a squared is equal to b squared equals c squared.
Yeah.
If you have two legs, could you find could you say that the hypotenuses were congruent?
Typically what they do is they don't give you the length of what that, oh, I understand what you're saying. Like, say you knew a triangle was a right triangle and you knew 2 of the legs, but you didn't know what the hypotenuse was. That's a really good question. By Pythagorean theorem, it would force those hypotenuses to be congruent because the legs are the same and you have that theorem that's there. I've never seen that done like in a theorem before, but I totally get the logic. But if you didn't have, so if you had a right triangle and you didn't have the hypotenuse, what you would have is 2 sides and an angle, and you'd be able to do side, angle, side. Like, let's say we had this triangle here, whatever, there's a right triangle. So if you knew instead that, whatever, let's say we use your assumptions. I know these, right? I know this side, and then I know that side. It would be side, angle, side.
Yeah.
So instead of using Pythagorean theorem to force that other side, which is legit, you don't need to, because you would just have side, angle, side every single time anyways. Because your hypotenuse is always across from your right angle. So then you'd have the 2 sides connected, the 2 legs, and then the right angle. So it'd always be side, angle, side. So that's a really good idea, though. I like that. All right. Let's do, 7's pretty simple. I don't feel like writing out a full proof for number 7, but let's talk about it. How would you guys have done number 7? They give you 2 pairs of angles. Tegan would say that we need another side, right? What side could we get? Angeline? Yeah, so the one in the middle, QS, my reflexive side. So that would be a really short proof. That'd be a 3-step proof. You list your givens, you say the side that Angeline said, and then you would say that the triangles are congruent to each other by angle, side, angle. I'm not going to write a proof for that one because that one's really short. Instead, let's do number 8. Let's do 8 together. All right. Now, notice the proof statement for this one is different than your other ones. Your proof statement, instead of proving triangles congruent, it wants you to prove a pair of sides congruent, okay? At the end of the lecture yesterday, I said if you can prove the triangles congruent, then from that, you can get that all the rest of the pieces are congruent to each other, okay? So then what I'm going to do is I'm going to prove these triangles congruent like normal, and then try to get that last piece. How long does it take to take a picture?
They gotta take like a whole set of pictures.
Woof.
Long line, huh?
All right, thanks, Landon. Make sure you show me your homework at some point, okay? All right, so let's do number 8. So Landon, we're on the back of that worksheet. We're about to do number 8 together. Okay. All right. I've got just one statement, or one given rather. So GK bisects angle FGH and angle FKH given. All right, they didn't tell me that any pieces were congruent or anything like that. We're going to have to get that from the given itself, okay? So GK, this side in the middle, is cutting each one of the angles it connects to. So you guys tell me, if I say angle bisector, yes. So now our job is to figure out what are those equal parts, okay? And you guys tell me, what am I going to get? If it's an angle bisector, I better get 2 angles that are congruent to each other, right? So what do you got? What's it going to be? Where are my 2 angles at? Let's start there, maybe. You said what? FGK. So then this angle right here, and then HGK. Good job, Landon. So then angle FGK is congruent to angle HGK. Good. So then the other side, right? FKG is congruent to angle HKG. Okay. If you struggle with how to pick that out, it tells you that the segment is bisecting the angle. So then go to the angle FGH, which is here, and realize, okay, that's being cut in half. So that's why those two pieces are congruent. And then go to FKH, that other angle is being bisected. So then these two angles would have to be congruent to each other, okay? Now I need my reason why. Some of you guys are struggling with like your reasons. What would be my reason for this one? Yeah, you have to go with what they gave you. They gave you that something is bisecting an angle. So we're gonna say oftentimes that's a definition, not always, but definition of angle bisector. Good. All right, I just got two angles. I used my only given for all that it's worth. So when that happens and I still need more information, I should go back to the picture, right? So what can I get from my picture? You said what, Tegan? Which side? KG is congruent to KG. Why? Yeah, what would I put under my reasons? Good, reflexive property. All right. Did I show enough to show those triangles congruent? Yeah, I have two angles on a side, right? Is it going to be angle, side, angle, or angle, angle, side? Angle, side, angle. Good, Haya. And you get that from the picture, right? We have an angle here, and then a side in the middle, and then also that angle. That side connects those two angles. So then I would say this, even though it doesn't tell me to prove the triangle is congruent, we have to. So triangle, I don't know, FGK is congruent to triangle HGK. And you got highest said angle, side, angle. All right, great. Now I know the two triangles are congruent. That means all of their pieces, parts are congruent. So can I say that FK, this side up here, is congruent? So can I say FK is congruent to HK? Yeah, because I know all the pieces are congruent. So then I would just go ahead and say that. Just adds one extra step. FK is congruent to HK. That's what I wanted to prove. What is my reason? CPCTC. Corresponding parts of congruent triangles are congruent. Okay? That's kind of where we left off yesterday. All right, so when you have a proof where they want you to prove a pair of sides congruent, pair of angles congruent, that part in blue is your only extra step that's different than normal. Okay? All right, questions there? Okay, I'm going to give you guys a cheat sheet. I'm going to give you guys a reference sheet. I was told I can't call it a cheat sheet because I'm not going to let you guys cheat with it. If you're struggling with figuring out like what reasons to rate, this is going to be a good tool for you. It's also just a good exercise for us to do in general. He does not do what it is.
Where was this in chapter 1? Brady Hines on it? I know all of them just got it. Who?
Now, I'm also going to give you guys your homework for tonight as well too, but I'm gonna do this reference sheet with you guys first. I just the bell rings, so you guys already have it. Reference sheet to the end of the bell. What time does the bell ring?
I think it's like 36.
It's 34.
They're going.
I mean, it went into the wrong one.
I'm dead on.
All right, here we go. I wanted to give you guys the practice quiz first. That way, yeah, okay, all right. Proof reference sheet, here we go. I developed this a couple years ago with my kids in the past, and I think it's been beneficial for them, so I'm sure it'll help for you guys as well, too. All right, so here's how this is structured, okay? The first part is, on the left, things that you may be given, right? So we start a proof by looking at our givens. So on the left, it's like, okay, this is what a given statement might look like. In the middle are things that you can list based on that given statement, okay? And then all the way to the right is the reason that you would write for that, okay? So think of a common vocab word that you guys have seen in your given statements. I'll let you guys do a little bit of the driving, and then I will take over. Midpoint. That's a sensational place to start, Probnor. All right, so you might be given, let me say this. I don't know how concise I want to be, but let me do this. Let's just say like A is midpoint of BC, okay? I could have just written midpoint, whatever, but I guess I kind of want to write what the, you know what? I take that back. You guys can leave that statement. Don't change anything. Don't change anything. But if you're given, I'm going to write it like this. So if you're given a midpoint, okay? That's all you need to know. Whatever. If you want to change it, write midpoint, doesn't matter. What can you state from that if you know that something is the midpoint? Well, so that would be our reason, right? So Ryan says definition of midpoint. That would be the reason that we would write down is definition of midpoint. But what would you write as a statement? If you know that something is the midpoint, what would you write as a statement? What did I say? A is the midpoint, right? Of, what was it, like BC or something? So you could say like BA is congruent to AC. Or you can write two congruent segments. Okay? So if you're given a midpoint, that means I can say that two segments are congruent to each other. Okay? What's another common vocab word that you guys have seen as a given? Or any other type of given you might have seen? Do you want to do segment or angle? Okay, so let's say you were given an angle bisector. What does that mean if you're given an angle bisector? So two congruent what? Angles. Good. All right. And then what would our reason be? Definition of angle bisector. Good. The other kind is segment bisector, right? So let's say segment bisector. That's not normally how it looks. Normally it'll say like this segment is bisecting another segment. So you kind of have to read between the lines from that. But what you would get is two congruent what? Segments. What would my reason be? Definition of segment bisector. Good. I'm abbreviating it. Hopefully you guys are all right with that. Okay. All right, what else? What other vocab words have you guys seen? Perpendicular lines, right? So if you were given, let's say, let me change the color for this one. Perpendicular lines, okay? One line is perpendicular to another line. What can you get from that if you know two lines are perpendicular? Two right angles, okay? So I'm going to state two right angles. And then what's my reason? Definition of perpendicular lines. Notice I don't state that the angles are congruent, okay? Instead, I state that I have two right angles. Okay? Well then, so let's say this. Let's say you are given, or you know somewhere in there you have 2 right angles. Okay? Here's what I'm going to have you guys do. All right? I'm going to put a dash underneath where we put that given. Okay? So you see I'm going to put a dash there. Because there are 2 things that you can state if you know you have 2 right angles. So I'm going to put an arrow. Okay? You don't have to put them both. Usually you do one or the other. Okay? What do you know if you have 2 right angles? What's that? They equal 90. They also equal each other, right? So what you could say is you could say 2 congruent angles. That's one option. And then your reason for that would be right angle congruence theorem. So if you have 2 right angles, one thing you can say is that those angles are congruent to each other. Okay? Right angle congruence theorem. The other thing that you can say from that, though, and we did this in your homework yesterday, and the one that I did with you guys on the board, if you know you have 2 right angles, what type of triangles do you have? 2 right triangles. So I'm going to say the other thing you could say is 2 right triangles. And then the reason for that would be definition of right triangle. All right, that was a good one. What else could we have been given? What else have you been given in the past?
Segment is congruent to another.
2 segments congruent to each other. From that, we would just leave it as it is, because usually what we're after anyways is like congruent segments or congruent angles. So there's not much more that we can get from that. What else? There's a big one we haven't talked about. Like angle sum theorem, triangle angle sum theorem. You wouldn't usually be given that, but it is something we have to use a lot. Braden?
Supplementary too.
I guess one thing you could be given is like 2 angles form a linear pair, and then you could say they add up to equal 180 from supplements theorem, but I'm not going to put that on there. But we did work with supplements theorem in the past. It's a good reminder of it. All right, how about this one? Parallel lines. If you said it, I'm sorry, I didn't hear it. If you know that lines are parallel, what do we get from parallel lines? You get 2 congruent angles, right? So 2 congruent angles. Here's what I'm going to do. I'm going to put a dash under parallel lines. I'm going to put a dash under 2 congruent angles. Usually you can say they're congruent for one of 2 reasons because they're one of 2 types of angles. Any ideas? 90% of the time, they'll be alternate interior angles. So I would say alternate interior angles theorem. 10% of the time, we would say they are corresponding angles theorem. And of course, that just depends like on your picture and what you have in your picture. You just kind of have to see what you have there, okay? There are more things that I want to add on there, but I'm going to wait. I want to go down below, okay? What are 2 things that you should look for in every picture? What are 2 freebies?
Okay.
What type of angles? Look for vertical angles. And then you would use vertical angle theorem. And what's the other freebie we can get from a picture? Not a right angle. Not an angle, but a side. What type of sides? You said what, Julia? Reflexive. That's the other freebie you can get from a picture is reflexive sides. What are the 5 ways we can prove triangles congruent? Somebody give me one. Tegan, they got you busy today, buddy. Side angle side. What else? Hey, Mrs. D'Amico, thank you. What else? Side, side, side. What else? Angle, side, angle. What else?
Side.
Angle, angle, side. What's my last one? HL. I probably don't have time to write out the part that's to the right of that. But I don't know. We'll do that tomorrow. Okay. I gave you your practice quiz. Do that for homework tonight. Tomorrow we'll go over that in detail. We'll probably finish this. Is this helpful?
Nope.